Now let's look at purifying the water we drink. How is the water we drink purified? Okay, so the first step to purifying water is removing particles and bacteria. Okay, so that's the very first step. So when we have any water, if we want to take a first step to get it purified, it will be to take care of all the bacteria and to take care of all the debris or the particles in them. Okay. So imagine that this is water right here with impurities. So if you have impurities in water, what do you do? The first thing we do is that we are going to add slake lime and aluminum sulfate to the water. So when we add this, it is going to react to form gelatinous hydroxide. So it is going to make sure that these particles they come together to form a clump. Okay. And so once this clump is formed, it is going to settle at the bottom. Okay. Once it settles at the bottom, the water is now aerated to improve the taste and smell. So, when we say aerated, what we mean here is that we're just going to bubble air through the water. Okay, we're going to bubble some air. We'll make sure that it's exposed to air. Okay. Then lastly, the water is disinfected with chlorine gas. So take note that if I come back here, once you have these debris settling at the bottom, you can easily filter this. Okay. We can easily filter these debris and we aerate the water, and then now we are going to disinfect it by adding what? Chlorine. So chlorine is a very good disinfectant. So when we add chlorine to the water, it's going to kill all the germs and all the bacteria. Okay. Which of the following is not a method of disinfecting water? So we know that boiling is a method of disinfecting water. We know that chlorine gas is a method of disinfecting water. But aeration is not a method of disinfecting water. Okay. Now let's talk about seawater. So we can convert seawater into drinking water by doing what we call desalination. Desalination simply means that we remove all the salt in the seawater. Okay? By removing all the salt in the seawater, we can convert seawater into what? Drinking water. And one of the methods of doing that is using distillation or reverse osmosis. Okay, the two methods of doing desalination is distillation and reverse osmosis. All right, so this is actually, you can have salt water right here. You have a glass, you have fresh water at this point. Okay, and then this one here is a black silicone lining. All right, so this is reverse osmosis right here. So if you have water, you have a semi-permeable membrane, what is going to happen is that there will be a net flow of water molecule in that direction. So if you have fresh water here, you have a solution on the other side. Okay? So these are all methods of purifying water. So this is osmosis, this is equilibrium, this is reverse osmosis right here. So with osmosis, what happens is that you have fresh water that is going to leave, that you have fresh water on one side and you have salt water on the other side. Okay. So with reverse osmosis, the fresh water is going to pass across a semi-permeable membrane into the salt water. Okay. And so in this one, that's osmotic. This is equilibrium, which means that water is moving in both directions, from the freshwater side to the saltwater side, and from the saltwater side to the freshwater side. But with reverse osmosis, it is instead it is instead going to move from the saltwater side to the freshwater side. Okay? And that is because we have an external pressure that is going to be applied to cause the reverse osmosis. Okay. So now when we're talking about screening, so screening, what it does is that it removes large insoluble items, right? Items that are large and insoluble, screening is going to do that removal. So the primary treatment allows smaller insolubles to settle to the bottom or to rise to the top. so they can be removed. Okay. While the secondary treatment aerates the water and allows finer particles to settle for removal. Then we have a tertiary treatment, okay, which is that filters the water. Okay, so this is actually a plant right here. So this is a plant right here. So just look at, imagine that you have a raw sewage right here. You have water that passes through a waste screen. So this screen here is going to take care of all the large insoluble particles. It removes all of that. So the water now moves to this grid chamber right here. In this grid chamber, what are you going to get here? You get what? You're going to get some filtration right here. And so the water goes now to the sludge. And here you will have what you will get here. You will get, so you have a sludge right here that is going to take care of, like, if you look at the solid, these all this sludge, all the large particles that were removed from the water are going to go to a disposal site. Now the remaining water is going to continue for a secondary treatment. So take note that the secondary treatment, it is going to, there's a chlorine tank here. So chlorine is going to be released into the water to make sure that all the germs, the bacteria are being taken care of. Okay. So now the next thing is that the water now goes to an aeration tank. Okay, so there are blowers right here that are going to make sure that the air is being bubbled through the water, and then the water moves again to a settling basement. Okay, so this is a different treatment from this one right here. So this one example, this another example, whereby water goes through an aeration tank, air is being bubbled, and then it goes to a settling basin. So all the solids, when they settle to the bottom, what happens is that they are going to be collected through a waste disposal site or incinerator. And then now chlorine is going to be released to kill all the germs of bacteria. Okay. That is that for water treatment. Okay. And that's that for this unit.